Chips, the electronic midgets of our time, are all around us. In gadgets that we use daily, as well as in highly technological apparatus, from the electric toothbrush to the jetliner. But what is a chip really? A little plate of silicon with a size between 1 and 4 square centimeters. It all starts with quartz sand or silicon dioxide, a raw material found abundantly in nature. Subjecting the sand to a complicated chemical process yields an ultra-pure silicon monocrystal. From this monocrystal, thin disks of 1 millimeter thickness are sawed off, the so-called wafers. Using lithographic methods, the structure of many chips, that is, the transistors and their connections, is transferred onto the wafer. Finally, the wafer is sawed up into the individual chips. A transistor is an electronic circuit comprising a source, a sink, and a gate. The charge on the gate determines whether or not a current can flow from the source to the sink, that is, the gate is either closed or open respectively. Several transistors can be combined to form various logic gates, for example, an OR gate. A modern chip can have up to 30 quadrillion transistors on it. The point of a pencil can cover more than 100 million transistors. There are other amazing facts about transistors. Today, the worldwide production of transistors is 20 trillion pieces per second. Though the population of the Earth is growing rapidly, only 5 babies are born every second. This means that, in a sense, each baby receives a birthday gift of 4 trillion transistors. But it all began very slowly. In 1956, Shockley, Bardeen, and Brattain received the Nobel Prize for their invention of the bipolar transistor. In 1965, the annual production of transistors was 1 for every person in the world. In 1985, it had risen to 40,000 per person. In the year 2000, it was 65 million per person, and today, in 2020, it has reached 81 billion per person. No other product is manufactured in such numbers. In 1950, a transistor radio with 5 transistors cost around 500 euros in today's terms. Nowadays, a mobile phone with millions of transistors costs about the same. A simple comparison. A pound of rice has about 25,000 grains and costs around 1 euro. This euro will buy 500 million transistors on a memory stick, meaning a transistor is thousands of times cheaper than a single grain of rice. The lithography of chips, that is, transferring their structure onto a wafer, has changed significantly over the last years. Until recently, an excimer laser with a wavelength of 193 nanometers was used in a photo-optical process. The laser beam traversed a lens system and projected a photographic mask onto the wafer. This mask was transparent and contained the chip's structure at 10 times the size it would eventually be on the chip. As the size of the structures became increasingly smaller, today there aren't only 7 nanometer processes but even 4 nanometer ones, new and highly complex imaging methods had to be developed. In the extreme ultraviolet, the EUV method, a high-energy CO2 laser beam targets about 50,000 droplets of tin per second in a vacuum, vaporizing them into a gas plasma which generates a 13.5 nanometer EUV beam. This beam is then reflected via a metal mirror onto a metallic mask. From there, A system of metal mirrors guides the beam onto the wafer. Optical lenses would immediately be destroyed by this short-wave light. A complete EUV wafer stepper, of which only very few exist worldwide, costs more than 100 million euros. Finally, we need to point out the difference between memory chips and logic chips. Memory chips consist of memory cells for the individual bits. They are arranged in a matrix structure, with one memory cell comprising up to 6 transistors. These chips are fairly simple in their design and require no complex mathematical methods. Logic chips, on the other hand, have highly complex structures and are designed with the help of many different mathematical procedures. In this exhibition, we will cover only logic chips and their design. The design process of logic chips is based on the methods of discrete mathematics. These are being developed in the Research Institute in Bonn. For example, the fastest supercomputer in the world, Summit, works with logic processors designed with the help of the tools and methods developed in Bonn.